Good morning, everybody. My name is Ningbo, a professor working at the Sichuan University, China. It's my great honor to be here. I will give my presentation from these 5 aspects. First is the personal preview. You can find the basic information from the slide. I received my bachelor's degree and doctorate degree from Northwest Agricultural Forest University in 2004 and 2009, respectively. After graduating, I joined the Sichuan University as a lecturer and became an associate professor in 2014. From July 18, I became a permanent professor. As for academic activities, I'm the vice chairman of the Agricultural Water and Soil Engineering Professor Committee of the Chinese Society of Agricultural Engineering, member of the Surface Water Committee of the Chinese National Committee for the International Association of Hydrological Science. I'm also a member of the Board of Frontiers in Plant Science, Agriculture, Chinese Society of Agricultural Engineering, and the Journal of Irrigation and Drainage Machinery. Moreover, I serve as the reviews of many journals, such as Journal of Clean Production, Journal of Hydrology, Agriculture and Forest Meteorology, Agricultural Water Management, Hydrological Process, etc. I received 25 research project grants, served as PI, and a total of 35 grants completed or ongoing with total funding in $3,487,000. I have published more than 133 academic papers, including 88 SCI indexed papers, with a cumulative impact factor over 20 and 13. I scored an H index of 27 based on scores. There are 6 papers with me being the first author and corresponding author in total, of which 51 are indexed by SCI and 25 by EI, with a total of 1,595 citizens. I participated in the completion of 2 national planting textbooks, had 36 national patents published and processed, obtained certain software copyrights, and set up 6 local standards in Sichuan province. Here is the awards and honors I received. Total number is 15, including 2 national science and technology awards and 6 professional science and technology awards. I won a piece of 17th China Young Science and Technology Award and the famous Sichuan Young Science and Technology Award, the second prize of Sichuan Science and Technology Progress Award, the second prize of 2022 Environmental Production Science and Technology Award, 3 second prize of Agricultural Water Saving Technology Award, and 1 first prize of Sichuan Science and Technology Progress Award in 2016. Nowadays, agricultural water use has become the main battlefield of water saving. In recent years, with the continuous increase of efficient water saving irrigation areas, total amount of agricultural water consumed has shown a significant decline. However, with the improvement of living standards, people's demand for high-quality fruits is increasing. The development of water saving quality improving, and efficient increasing irrigation is an important strategic demand to ensure food and water security. We have established a new method of using live APA value and defective irrigation to indicate the level of crop response to drought stress, which the simulation accuracy can be improved by 18.7%. We established a new stormwater conductance model by considering the response of water vapor pressure differences to water defect, which the simulation accuracy can be improved by 18.1%. Based on the response of photosynthetic parameters to water defect, the optimal stormwater conductance and reagent transpiration regulation thresholds of high water using efficiency were identified. We also investigated the mechanism of water saving and yield maintenance based on the dynamic regulation of vegetative growth and reproductive growth. Mild and moderate water deficit at the early growth stage can effectively reduce standing growth, optimize canopy structure, and improve canopy light interception capacity. After revolting, the overall compensation effect induced by the rehydration significantly increased the photosynthetic rate of leaves, promoted the transfer and accumulation of fertilizer to reproductive organs, and then increased the fruit growth rate and soluble sugar content. Based on the effect of water deficit on the activity of key ingredient mice in fruit quality, the mechanism of fruit quality improved was realized. Testable acid was significantly correlated with acid invertase, and soluble sugar was significantly correlated with natural reductase. The results on the analysis of the effect of defective irrigation on fruit quality and its mechanism were commented by Xiao Zhongkang in Journal of Experimental Botany. The achievements of technical models for water saving and quality improvement of fruit trees were commented by Prof. Albert in theoretical and applied genetics. Based on the theory of information in tree, the comprehensive benefits evolution model of fruit and defect irrigation was constructed, and the quantitative evolution of fruit quality was realized. The crop rot and fertilizer fruit quality model was innovatively established to realize the quantitative characterization of the response of characteristic fruit quality to water regulation. We also established the new method of using the table carbon isotope discrimination of different organs of fruit trees to indicate the water using efficiency and water deficit. Defective drip irrigation significantly reduced the stable carbon isotope discrimination of kiwi fruit. Stable carbon isotope discrimination of kiwi fruit leaves was significantly negatively related to WEN and WEY, and defective drip irrigation, and stable carbon isotope discrimination of kiwi fruit was significantly positively related to it. Model of photosynthetically active radiation substance were improved by considering the light transmission process where the canopy and the vertical change of canopy life area with canopy height, and the quantitative expression of the amount of photosynthetically active radiation substance in the canopy can be realized. The total canopy productivity of fruit trees was calculated based on the proposed model, and it was found that water-effect treatment was beneficial to photosynthetic products accumulation of water canopy because it reduced the fruit tree's redundant vegetative growth. Studying the non-linear relationships between key environmental variables such as soil water content and air temperature, and crop transpiration and soil evaporation. A simple predicted model was established for water crop demand based on the Gray prediction algorithm. The predicted values were in agreement with the observations and was also comparable to other reliable methods. Professor Busari of Punjab University in India commented that using stable carbon isotope technology to indict the water using efficiency of fruit trees is a simple, direct, and effective method for rapid and accurate evaluation of plant use efficiency. Galindo team of Trent University commented that the difficult irrigation results provide a new method for effectively regulating nutrition growth and fruit development by using the compensation effect of irrigation rehydration. In this study, we considered the thought that the Bayes theory can update the establish the empirical parameters based on the posterior distribution. The accuracy of ETO estimation obtained by HS model was significantly improved, with the error of estimation value of soil radiation rising from negative 6.8% to 5.7%. Moreover, 7 simplified ETO established models which only take air temperature as input were built after coupled with the HS radiation model. Among the 7 models, the relative error of M5 mod with the highest accuracy is less than 8%, which breaks through the problem that the calculation of crop demand requires massive methodological data, and the estimation accuracy is low for a long time. Based on the accuracy discrimination among the radiation models, novel ETO models were proposed by coping with the FAO Homogeneous model, which the problem is that the high precision ETO established values cannot be obtained in some missing area. Furthermore, the extreme learning machines improved by particle swarm optimism and long short-term memory improved by deep belief networks were developed, respectively, which significantly improved the estimation accuracy of ETO at different climatic areas compared to other original versions. The irrigation schedules of various characteristic fruits and different irrigation methods in southwest China were obtained, and the drip irrigation work and fertilizer integration of that was conducted. The drip irrigation system of more than 10 kinds of fruits and vegetables was established, which provided important theoretical support for modern agricultural water saving and quality improving irrigation. The irrigation schedules of various characteristic fruits and different irrigation methods, such as drip irrigation, and film, in southwest China were obtained, and the drip irrigation route and fertilizer integration of that was also constructed. The achievement about improved high gravities was created by Professor John Wick at Computers and Electronics in Agriculture, and they reported that the improved model has achieved ideal production accuracy with only temperature data as input, which is of great significance for precision management of farmland water. That is all my presentation. Thanks for your attention.